think we're going to hear something in a second, so I'll mute it on the playback. And yeah, otherwise I get like the infinite regression. But you know what happens when you play with the infinity zone, right? Ooh, let's see. Okay. I think we're going to hear something. Oh, yeah, there we go. We're going to mute that video. Okay, here we go. Mute that video. That's me. That's me in the background. Okay, so back to our story. We have location, location, location. We're going to go over that. Your homework is here. If you want to start practicing the names of the stars, remember we need to know proper name, common name, and nickname. You can click on this link and you can actually take a quiz. It's actually pretty easy. And it'll give you 10 random questions, and they're going to be related to the constellations we've been learning. So number 5, if you take a look up there. Anybody know what number 5 is? Right here, number 5. Say it out loud if you want. Anybody recognize it? Little number 5.
Triangulum.
Very good. So you'd find triangulum. And what's the common name for that?
Triangles.
The triangles. Okay, so there we go. It's pretty easy. But again, you're just trying to practice to get those names together. How about number 3? Who knows number 3 with these 2 branches coming out of it? Anybody recognize that one? We're going to practice this again, by the way, the best we can. Anybody recognize it? There's supposed to be a big circle here. Pisces is right. That's Pisces. Pisces the what?
Fishes.
The fishes, right? You guys see how it works? You can just practice. It's free. It doesn't count for anything. It's just to practice. And again, if you try to remember the names and you want to practice, this is a way to practice. You've got it right on canvas. And then you can check and see how you're doing. Okay, what's object number C? Anybody know the name for the eye of the bull? The name for the eye of the bull. You can
Taurus.
actually, Taurus is the bull, but what's the name for the eye, the star, which is the red supergiant, which is the eye of the bull?
Oh, is the Beetlejuice?
It is called Aldebaran. Aldebaran, right? Aldebaran. Okay. But again, you can practice and try it out. And what's star G? Who knows star G right here in the constellation of Orion? G. Recognize it? Blue supergiant. Rigel. That's Rigel. Good. That's right. Okay, you guys see how it works? Okay, and you just submit it at the end and you get a grade. I know I didn't finish. I know. My students are going to do it. Okay, did I get 4 points? Hopefully I got 4 points. I don't know. I can't see my score. Does it tell me my score? Points, 10. Oh, I got 4. See, I got all 4 right. Woo, I'm so good. Okay, here we go. Back to our module. And finally, let's go ahead and talk about what we want to do. Oh, here, participation quiz. After today's lecture, you can take this quiz. You get 3 tries, but hopefully it won't take you 3. And you want to get all 10 points. Now, if you don't get the questions right at the end of 3 tries, you will not get 10 points. So please do your best, okay? It shouldn't be too hard. It's based on what we covered tonight. And it's meant to be the big ideas that we covered tonight. So let's take a look at week 3, location, location, location. Okay, that's our meeting link. We're going to practice the constellations right now. And then we're going to talk about sheets 5A and sheets 5B. And they bring up some really cool ideas that I think you're going to enjoy learning about. So yeah, I got a question or a chat. Rigel is right. Oh, good job. Thank you, Aria. Yeah. All right. So let's go ahead. I'm going to stop the share and I'm going to jump to Stellarium. Remember I told you Stellarium is your personal planetarium software. I'm going to jump to Stellarium right now. And I'll show you, actually, I want to demonstrate how you can use some of the cool features in Stellarium. So here is a window looking at the sky. And as you can see, it's daytime, so I can't see the stars. But if you scroll down right here to the bottom, this window pops up, this little bar, and I can turn off the atmosphere, or I can click the letter A, right? And that allows me to do it. And then I usually just pause so that I can set the time myself. You can scroll in and out to see more of the sky, right? And actually it's showing me some of the stars. We'll go ahead and I can turn that off. Maybe I should turn that off. I should turn that off. Let's turn that off. So show me the labels for the stars. Okay, there we go. And then, yeah, let's go ahead and get started then. So we're going to move forward in time. The way you do that is right here. You're going to move forward in time. We'll go ahead and go to, let's go to 7, 8, Yeah, 8 o'clock at night. So that's maybe even 9. Should we go 9? No, 8 o'clock at night. That's perfect. Okay. In fact, maybe I can't see what I'm looking for. Let me go back just a little bit. In fact, I'm gonna go back to 7. Yeah. Okay. Here we go. So we're gonna look over in the western part of the sky, and it's a little hard to see stuff, but let's go ahead and try. Does anybody know the name of this 4-star combination? Go ahead and say it out loud if you know it. 4 stars. The proper name. Anybody recognize it? Okay. Everybody say, you can say it to yourself. Everybody say Pegasus. That's Pegasus. Okay. So what is Pegasus? Anybody remember that one? You could unmute yourself if you want. Or not. Okay. That's right. That is called the flying horse. So Pegasus is the flying horse. Remember, the proper name is Pegasus, and the common name is the flying horse. It's this 4-star combination. And this star, oh, so one more name though. What's the nickname for the 4-star combination Pegasus? It is known as the
Flying horse.
Square.
Well, that's the common name. What's the nickname?
Big square.
Great
The
square.
Great Square of Pegasus, right? Now, this star does not actually belong to Pegasus. I'm going to turn off the lines because I want to see it. There is a branch of stars that follows here, and then a dimmer branch that goes here, and they are a constellation. Do you remember the proper name of the constellation? A little funky here. This is called Andromeda. Everybody say Andromeda. You can say it to yourself. I know. If we were together, I would ask you to say it out loud. And what is the common name of Andromeda? This is the artwork that you're going to see. The chained goddess, right? She is the chained goddess. So I can see it. She's wearing manacles or handcuffs. She's chained to a rock, right? She's actually, we're going to hear that story. Again, probably not tonight, but at some point in your future, you'll hear that story. Okay, now, if you, I'm going to rotate this guy a little bit and actually look right here at this arc of 3 stars. This 3-star arc is actually something we want to look for. Does anybody remember the proper name of that constellation? Got this 3 stars that arc over. It's called Aries. That's Aries. And what is the common name for Aries? Anybody want to try?
Ram.
The ram. So that's Aries the ram. So we have this ram right here with the horns and everything. And the reason why we need to learn that one is if you follow this curve, you find this star here, which leads to this 2 branches of stars coming out of it. What's the proper name of that constellation? That one was called, that was Pisces. Pisces, and we already said Pisces before. Pisces is the fishes, right? The 2 different fish that we have. Up here, we have above the 3-star arc, we have a 3-star combination. It's a little, I'll turn the lines on just to see it again. And we said this one was called Triangulum, the triangle. You guys did that one as well. Okay, now I'm going to turn away the line, take away the lines. We have Pegasus, we have Andromeda, and then we have a sweep. We have a constellation here. There's a sweep of the arms, and then there's some legs. And this is the one that saves Andromeda. What's the proper name of that constellation?
Perseus.
Perseus is that one, right? Perseus. And because he saves Andromeda, we call him the Perseus,
Hero.
the hero. And don't forget, he's got a head on his belt. It's the head of who? Whom? I don't know.
Medusa.
Medusa, right? And so this special star right here is known as the Eye of the Medusa, the demon star. Who remembers the name of that star? We derive the word alcohol from it and the word ghoul, right?
Algol.
Algol, that's Algol. You can find the name Algol up here in the sky, okay? So in this software, if you click on a star, the name comes up along with way too much information. And then if you right-click, I'm a Windows user, it goes away, okay? So next to Perseus in the sky, we have a circle of stars, and I should turn that off here. A circle of stars. Everybody see the name? What's the proper name? We just added on a second ago. It's called Auriga. Auriga is the proper name. What was the common name? It's his day job. He's the what?
The charioteer.
The charioteer. But when you look at the artwork, what do you see? Right? He's holding a
It's a lamb, baby.
a goat, actually, a mama goat. And the name of the goat is one of the names of the stars that you want to know. What's the name of the goat? The star here. You like to sing, you'll remember this. It's called Capella. Okay, Capella. And right near Capella, you'll find 1, 2, 3 little stars. These are the baby stars. They're the baby stars. They're the kids, right? The kids. Okay, down below, Auriga, right here, we have a cluster of stars. Who remembers the name of the cluster? Called the Pleiades cluster. Okay, I'm not seeing that yet. Hold on. I know there's a way. There's a way. Actually, I should tell you. I'm not getting it. Okay, hurry. I'm not getting it. Okay, I'll show you a little trick. Over here, there's a search thing, and I can actually start typing the name. Pleiades. Oh, there it is. That's what I want. And there it is. Pleiades. Yay! Anybody remember the number? M45. That's the number we want. And you can zoom in. It's actually kind of cool. I think I can't. I don't know. There it is. There it is. Cool. And if you look closer, you begin to see this blue glow around the stars because the stars are flying through a cloud of gas and dust. The light of the stars is reflecting off of the gas and dust, and we get a blue colored reflection nebula. That's the name for that, a reflection nebula. So zooming back out, we've got this beautiful two kind of looks like horns. I hope you can see that. And there's the body right here. What's the proper name of the constellation? Try it out.
Taurus.
Taurus, of course. And Taurus is what? What creature is that? Taurus is the bull, of course. Taurus the bull. And the eye of the bull, we said before. Anybody remember that name? Very beautiful Arabic name.
Aldebaran.
Aldebaran, right? Aldebaran, right? Which is a beautiful, beautiful name. Okay, so now rotating to the northern part of the sky. Here we go, northern part of the sky. I should turn off all the clues here to make it too easy. But we only have a couple of constellations to worry about. I'm going to move forward about an hour, maybe an hour and a half, okay? We'll start off with this one right here, this big one, huge one, actually. What's the proper name of the constellation? Everybody wants to remember. It's a big one, right? So you're going to say Ursa Major, right? Ursa Major. And what does Ursa Major mean? You remember what that? The big bear, right? And the nickname, because of the shape, is I heard you say that.
Big Dipper.
The Big Dipper. And if you use these two end stars, this one's called Doobie. I forgot what this one's called. Merak? Yeah, Merak and Doobie. If you follow these, how many steps will you take away from the Big Dipper? Anybody remember?
5.
5.
5 steps, right? So 1, 2, 3, 4. I messed up. Try it again. I don't know. Let me see. Here we go. 1, something like this. I don't know. 1, 2, 3. I'm messing up. How about I'll try again. 1, 2, 3, 4. Something like that. Okay. What's that star?
Polaris.
That's Polaris, the North Star, right? That's Polaris, and it's at the end of the constellation here. And I'm supposed to turn off the light. Let's pretend I don't have that. Okay, what's the proper name of the constellation that Polaris is at the end of the handle of?
Ursa Minor.
Ursa Minor, which means what?
The Little Bear.
The little bear. And the nickname because of that shape?
The Little Dipper.
The Little Dipper. Okay, good. Okay, so you want to practice those, and ideally the stars are out. And tonight, when the stars are out, no, not tonight. It's raining tonight, but tomorrow night it's supposed to be basically kind of clear. But tomorrow night, go out and practice. Try to see if you can see all those constellations. The way to get good is by practicing. Okay. All right. So now, what do I want to do? What do I do here? How do I do this? I don't know what to do. I don't know what to do. I forgot how to do this. What do I do? I don't know what to do. How do I do this? Can you guys see my picture? How do I make it so that my picture is the only picture? Hold on. Oh, there we go. How about that? Can you guys see me? Hi. How you doing? I'm just kidding. Sorry about that. I am really out of touch with this. I'm practicing. Here we go. Try this out. Okay, everybody get out your lab notebook and find page 5. Page 5A is what we're looking for right now. Page 5A. And on this page, we're going to see a bunch of little pictures, and we're gonna fill these out tonight. So I'm trusting you to do this. If you don't do it, then you won't get the credit. Okay, so please do it. And these are some pictures of different parts of the sky, and you and I are going to work together to fill them out. Okay, so I think, do you guys see my letters as backwards, or do they look good to you? Can you tell me? They look good? Okay, they look good. You don't see the E is backwards and the S is backwards. Oh, that's so funny. It's backwards to me, but it's good for you. Okay, I'm happy about that. So E is E. Okay, that's good. Good, good, good. You guys see, where's my pencil right now? On the right or on the left?
Left.
It's on the left. Okay, that's funny. Oh man, how do I do that? Okay, I'm not going to worry. It looks weird to me. It looks backwards to me, but I'm just whatever. It's not important. Okay, here we go. So actually, today's class is about how do the stars move in different parts of the sky. You need to know, like with some precision, how they move in the sky. So we're going to do our class today from the place where we're all living. I want you to write up here. We're in Santa Barbara. Make a note. This is Santa Barbara. So what do you need to know about Santa Barbara? Where is Santa Barbara? What piece of information do we need in our astronomy class? And you want to know, if you haven't thought about it before, I'm going to tell you that the key number you need is the latitude. You need the latitude. Does anyone know the number for the latitude of Santa Barbara? Approximately
34
what?
degrees.
About 34 degrees. Don't forget the N, which stands for what? N stands for north, right? So 34 degrees north latitude. Write that down on your paper because that's relevant. It's part of what we need to talk about. So when you're in the east, look in the east part of the sky. What are the stars doing in the eastern part of the sky? What are they doing? Say it out loud if you can. In the eastern part of the sky, the stars are they going up, going down, left, right?
They're rising.
They're rising. The stars are rising. So what I want you to do is make a little cluster of 3 stars near the horizon. And the question we have to answer right now is, how do the stars rise in the east? We're going to try to draw a very specific direction, right? How do they rise? Do they go straight up? Do they go straight up in the air? Do they go up and to the left, up and to the right? How do they go, right? And actually, we're going to try to be precise about this. Okay, everybody understand? So what we're going to do is we're going to go to Stellarium, and Stellarium is going to show us. So, and you could do this for yourself. You don't need the constellations, but all you need to do is look in the eastern part of the sky. Okay, so this is the constellation Leo, which we haven't learned yet, but there's a nice star right there. I don't know that. The nebula, of course I know that star. Okay, so the question is, I want you to predict. I want you to type it in the chat for me. Is this star going to go straight up? You could say up. Is it going to go up and to the left or up and to the right? Which one of those is the right answer? Type it in the chat. Type it in the chat. Don't be afraid. Please guess. Okay, it's all about taking a chance. Okay, so I want to see what you guys say. All right, so some people said, I got 2 answers so far. I need everybody to answer. Yeah, there you go. There you go. Thank you. Don't worry about being right or wrong. Just guess. The
Dr.
point
Kelly.
is that you're going to learn. One way or the other, you're going to learn. Okay?
Dr.
All right,
Kelly,
so we got your question?
would you be able to restate the question again?
Sure. This is a star. It's in the east. When it moves, we're going to see it rising. Does it rise straight up and to the right, or up and to the left? One of those is the right answer.
Thank you.
Okay. Okay. So here we go. I'm going to leave my mouse right here. Or no, I can't quite do that. I got to do this. Okay. So just watch it. Everybody see where it is? There's a number, azimuth 80, altitude 12. Okay. You can look at those numbers. I'm going to go forward an hour. Ready? 1, 2, 3, go. What did it do? Look at that. 1 hour. What did it do? What direction? 1 hour, another hour, another hour. What did it do? How's it moving? 1, 2, 3.
Right.
Up and to the right. That was the correct answer. And so actually we'll stop. Okay. And now I want you to draw some arrows, but we're going to try to draw something close to what's really happening. So I want you to draw a kind of a steep arrow like that. Draw 3 arrows for me like that. Okay. So what we're going to talk about in this class is that the way that the stars move is directly based on where you are on Earth. And we call the angle that the stars are rising at some angle above the horizon. We call this the rising angle. That's the rising angle, right? So what is the rising angle? How are the stars rising in Santa Barbara? Does anybody know what the number might be? Take a guess. It's not important. It's whatever, if you want to guess. Anybody want to guess? I'm going to look in the chat. Anybody want to guess? Number? A number? What number do you think it could be? It's pretty steep, though. All right. So nobody.
45 degrees.
45 is a good guess. That's a great guess. It's actually even bigger than 45. And so I want you to write down the number. The number is 56 degrees. 56 degrees. Write that number down. The rising angle. Do you guys know the symbol for angle? That symbol for angle? We're going to use that symbol for angle. And so the rising angle is 56 degrees. So that's the number. That's what it is. Okay. Now, if you remember, there's actually, I'm going to go to the southern part of the sky here. And I want to remind you that there's actually a line that goes down the middle of the sky, right to south. Does anybody remember the name for that line? It's got a special name. We learned it last week. The celestial meridian. Does everybody remember that name? It's just the middle of the sky, right? So I want to talk about the stars as they're crossing the middle of the sky. I'm going to put some stars in the middle of the sky, right at the middle of the sky. And I want to ask, how do they move when they're in the middle of the sky like that? Directly to the south. So I want you to make a prediction. Okay. Do they go up? Do they go right, left, down and to the left, down and to the right, up and to the left, up and to the right? I don't know, one of those directions. Go ahead and guess something. Just type it in the chat, whatever you think it might be. How do they move when they're in the southern part of the sky? So it's just a guess. And if you're wrong, it's no big deal. If you're right, it's great. Okay. It's no big deal, actually. It's just a little guess. Okay, good, good. Okay. You're making a guess. Okay. Excellent. Great. I'm going to take a little sip of my coffee while I'm watching you guys type answers. Everybody like coffee? Yum, yum. Okay. All right. You ready? Let's go ahead and check it now. Let's go ahead and check. So we're going to stellarium. And this time, we're going to look specifically to the south. Now, I could actually turn on, let me do this. I want you to see this. I'm marking, and remember the word meridian. I'm going to mark meridian, okay? And I want to find a star. Let me go ahead and look. This pretty, that's really good. Actually, how about that one? That's pretty good. Right there. That's on the meridian, right there, right there. It's called Lambda. What is that? Lambda Vel? I don't know what that is. What is that? What is that one? I don't know that one. Okay, I don't know that constellation. But anyways, lambda, that's a Greek letter. So the question is, how does that move? We're going to move it forward and actually backwards. I don't know if you can see something. You know what I think? Let's go a little higher in the sky. Does everybody see this star right here? Let's do this one. You can see which way is it going to go, by the way. Which way? To the right or to the left? What's it doing? Move an hour forward. What does it do? It goes to the right. It goes to the right. Yeah, it's actually moving to the right. Does everybody see right? I'm hoping you're seeing what I'm seeing, but maybe you're not. Are you seeing it move to the right?
Yeah, we see it.
Okay, good, good. Thank you. I'm a little backwards on this. Okay, but let's go ahead and take a look. The azimuth is 173. That means just a little bit to this side of the center. And then the altitude is 46 degrees and 22 minutes, okay? I move forward an hour, and it's just a little bit lower. It actually did go down a little bit. But I'm going to cheat and tell you that, in fact, at this moment that it's crossing the middle of the sky, the stars are going to just be moving to the right, just at this moment, just at this moment. So please draw arrows to the side, to the right. right? They're just at this moment moving to the right. And now we finally get over here to the western horizon. And the question we have is, what's happening to the stars in the western part of the horizon? They are setting, right? So how do they set? Now we know they're setting. Let's go ahead and put a cluster of stars. And we're going to watch these stars setting. But go ahead and type in the chat, what direction are they going to set? Is it going to be straight down? Right? Is it going to be straight down like this? Is it going to be down and to the right? Down and to the left? What do you think? What's it going to do? Type an answer in the chat. Okay, just guess something. Okay. So we're just guessing. No penalty. It's all good. Whatever we get is good. Okay. And so what we're going to do is we're going to test. We're now going to check, right? You have a prediction. You made a prediction. You guessed. And now let's go ahead and go to Stellarium. And we're going to check. Okay, so we're going to go over here to the western part of the sky. And I have, oh, look at this, Betelgeuse, Bellatrix, Rigel, and Saiph. Oh, I forgot to do those, didn't I? Oops. Ooh, how did I forget that? I didn't do a very good, oh man, I totally forgot Betelgeuse. All right, sorry about that. What constellation is that, by the way, since we're here?
Orion the Hunter.
Oh, Ryan the Hunter. Thank you so much. Okay, I forgot it. I forgot to do it. Okay, anyway, so we got Betelgeuse. Let's take a look at Betelgeuse. How does it move? Okay, so ready? We're watching Betelgeuse. Ready? 1 hour later, what's it do? What's it do? How did it change? How did it change? It went down and to the right. Okay, so it turns out, actually, it's kind of cool. If you see Betelgeuse setting, it sets exactly in the west, almost exactly in the west, and it rises almost exactly in the east. It's actually one of those constellations that you can use to figure out the direction. So Betelgeuse is almost perfectly in the west as it's setting, almost, okay? So we'll go back to our diagram, and I want you to draw kind of a steep angle. I want you to draw arrows going down, right? Going down. And this has a name. These are called the setting angle. The setting angle. I'm just going to make the symbol for angle this time. And I want you to go to the one that's all the way to the right over here. This one right here. I want you to put a little line. And I want to figure out what is the angle that it's pointing down at. Does anybody want to make a prediction? What angle do you think it might be? Take a guess. Good chat guess. Okay, let's see. I'm looking at the chat. I'm going to look for a number. What's the number?
56.
Yes, it is. It's the same angle. Okay, so what did we just learn about the way the stars rise and set? The angle that they rise is the same angle that they set with, right? The same angle going up is the angle for going down, right? So the rising angle and the setting angle are the same. We just learned that, right? The rising angle equals the setting angle. Okay, that's something you're supposed to know, okay? All right, our last one, but it's actually not really the last because I forgot. I need to add a circle, a square rather. Okay, I'm rotating. Okay, so the north is north. And by the way, in Santa Barbara, we have these mountains. What's the name of the special point in the sky that doesn't move? The special point in the sky that doesn't move.
Polaris.
That's the star, and it doesn't move very much, but it's not exactly the point that doesn't move. Does anybody know the name of the point that doesn't move?
North celestial
The
pole.
North Celestial Pole.
Yeah, go ahead and make a dot right there. And I want you to label that NCP. I want you to make sure you understand. The point in the sky directly above north is called the North Celestial Pole. And this is a special place, right? There's something special about that. Now, there is a star right next door to it. It's actually just slightly off of it. It's about 3/4 of a degree away from the North Celestial Pole. So I'm going to go ahead and put a star close to it. And this time a star a little bit further from it. And this time a little star that's pretty far away. So draw 3 stars somewhere. One close to the NCP, one medium distance from the NCP, and one far from the SCP. And our question is, how do the stars move near the North Celestial Pole? This is something we have to understand. This is one of your goals in this class. How do the stars move? Okay, so anybody go ahead and you can type a prediction in the chat, and I'm going to go ahead and bring up Stellarium. And before I do that, I'm going to go ahead and add that point called the celestial poles right here. And so I'm going to turn the sky right here. And where is the celestial pole? Where is it? Huh? Where'd it go? Oh, I'm in the wrong direction. Hold on. Try again. There it is. Everybody see NCP? So what's the name of the star right next to the NCP? That's Polaris, of course, right? No, what? What is that? That's not Polaris. What? Hold on a second. That's not. I must not be pointing at Polaris. What? I'm confused. What planet are we on? What is it talking about? What is it talking about? Hello? What are you talking about? This doesn't make any sense. Hold on. I'm confused. That's funny. Where's Polaris? Mismar? What the heck is Mismar? What the heck is Mismar? What the heck? This thing is telling me that Polaris has another name. I've never heard this before. Okay, I don't know what to tell you. Just ignore that. That's weird. I'm just confused. Okay, so what we need to do is try to understand, how do the stars move? You made a guess and you said, oh, good. Yeah. You can, that's good. Good job. Okay, everybody okay? All right, you got an answer. Okay. All right, good job. Okay, so now let's watch the stars. I'm going to go ahead and actually I will just start playing them. Everybody see how they're moving? How are the stars moving? Say it out loud. Somebody say it out loud. It's good. You said it right. What's the direction called?
Counterclockwise.
Counterclockwise. They move in circles, right? If they're close to Polaris, how big is the circle? Just a little circle, right? Just a little circle. If we zoom out, you can see it's just a little circle. The further out I can zoom, the more, right? But if the star is further away, the circle is larger. And if it's very far away, the circle is very large, right? That's the idea. We're going to pause that, go back to our diagram. And so I want you to think like that, right? If a star is close to Polaris, then it's going to follow a circle that's not very big, right? Around. And what direction? It's going to go the opposite of the clock, right? It's going to go in this direction. Going to go like that, opposite of the clock, counterclockwise. So counterclockwise around the NCP. Okay. Everybody read that? Let's see if I need to move that. There we go. Counterclockwise around the NCP. Now, if you're a little bit further, the circle is going to be larger. We have a larger circle, right? I didn't do a very good circle. I'm really out of practice. Sorry about that. So draw a bigger circle. There we go. Bigger circle. Not very good. Don't worry. I got a PhD and I can't draw circles. Okay, here we go. So I got a circle that's bigger. And what happens when the circle's really big? You see what's going to happen is the circle won't be visible all night long, right? We're going to lose this. This star is going to now rise and set because it's too far away from Polaris to be seen all the time. So the star we call Polaris is about 3/4 of a degree away from the North Celestial Pole. How far away can a star be from, oh, you don't know this yet. Sorry about that. Never mind. Sorry about that. I made a mistake. Can I just show you something though? I think I need to show you something important. Okay. So let's go back to our picture again, our stellarium. And I want to highlight something very important about the NCP. If you look right here on this celestial meridian, this is 30. This is 30, and this is 40. Does anybody tell me what the number is for the NCP? Approximately what number? 1, 2, 3, 4.5, I guess. It's very close to 34 degrees. Okay, so this is actually a moment of importance to you. Okay, so I want you to think for a moment. I'm gonna actually look in you. I want to look you in the eye. Here we go. I'm looking you in the eye. Where is the North Celestial Pole going to be in the sky? And in Santa Barbara, it has an altitude of 34 degrees above the north, right? In the north. Why 34 degrees? What's 34 degrees?
It's directly linked to our latitude.
That's our latitude. Okay, so if you didn't notice, that 34 degrees is the same as our north latitude. So what does this mean? If you change latitude, what's going to happen to the North Celestial Pole? What's going to happen? It will change, right? It will change to match your current latitude. So I'm going to do a little quiz with you right now. Are you ready? I'm gonna change to a random. Very good, good. Thank you, Lemoni. Thank you for that. That's good. We're going to talk about that in just a moment. Thanks. So we're going to change. Oh, you can't see this yet. I'm going to change my location to a random location in Canada somewhere. Okay, I'm not going to tell you where it is, but you're going to tell me based on your observations of the North Celestial Pole where we are. Are you ready? Here we go. I'm going back to the stellarium. Okay, I'm scrolling out because I can't see very well. Does everybody see the North Celestial Pole is way up here? So I want you to look. Let's see if we can estimate the number. Here's 60, right? 60. I think it should be. I can't read this very well. I think this is 70 actually, right? And this would be. No, I don't know. Okay, this is 70. This is 80, and this is 90. Okay, yeah, that's right. So what do you think? It looks like about almost 70, what? 71, almost 72, right? Pretty close to that. So where am I on Earth? Approximately, am I higher on the Earth or lower on the Earth? What do you think?
Higher.
I'm higher. I'm going to show you what I picked. I just randomly picked, and look at the latitude right here. 71 degrees, 36 minutes. I just randomly picked that, right? I didn't do it, for any intention. And if I pick another point, maybe down here in South America, 28 degrees south, right? I want you to think about what that means, right? Can you see Polaris in the sky at all? Is there any Polaris in the southern hemisphere? Can you see Polaris, the North Celestial Pole? Does anybody know this?
No, you can't see it.
You cannot. But I'm going to go ahead and scroll around to the south, and I want you to look something. Look at this. What do you see in the sky? This point that's sitting there, blue. What's that? The
Celestial Pole.
South Celestial Pole. And where is it? It's how many degrees above the horizon? Well, this is 10, 20, 25, 26, 27, about 28 degrees. What did that match? Our southern latitude, right? This is actually another special point. So this is a special point in the sky that we want to be able to identify. So the South Celestial Pole will not be visible to us, but it would be visible to somebody in the southern hemisphere. So let's go ahead and add a square. Everybody's going to add a square with me. Take a look. We're going to add in a square right over here next to this square that we had. We're going to add a square. We're going to go out to sea somewhere. There's going to be some ocean, and we're going to be deep in the southern part of the ocean. And right above that point, there's going to be a South Celestial Pole. And we normally can't see this, but we have gone to another location in the southern hemisphere, right? In the southern hemisphere. We're doing this, right? This is not Santa Barbara anymore. This is something different. But I'm going to draw a star that's close and a little bit further and then a little bit further. Okay, I want to think about that. So as we think about this, we're going to go ahead and start turning the sky. I want you to predict. Type in the chat. How do you think the stars will move near the south celestial pole? And yeah, what do you think? What's going to happen? Type in the chat. Which way are they going to move? How are they going to move? The same, different, how are they going to move? Okay. All right, let's see. Let's see. So you're all guessing. Ooh, very close. Actually, I see nothing but the same answer. You guys just copying each other? No, I'm just kidding. All right, everybody, let's take a look. Okay, so we start playing the video, playing the time, and you were right. That's actually what I would call clockwise. And it's the same idea, right? Except this time we're looking in the opposite direction. Instead of up at the north celestial pole, we're looking down at the south celestial pole. It's the opposite direction as we were looking before. And this time the stars are moving around on clockwise circles. Now, if you really want to get this, I want to show you something important. In the southern hemisphere, where do the stars rise? In the southern hemisphere, where do the stars rise? And the answer is, it doesn't matter where you are on Earth, the stars rise in the east. So what are the stars going to do? They're going to go up. But actually, how are they going to move? Anybody want to guess? Do they go straight up and to the left, or up and to the right? Make a guess. Type it in the chat. How do they move? Up and to the right, up and to the left. What do you think? In the southern hemisphere where we are right now, how will the stars move? And I see one person, one chat. Okay, I got one, I got two, I got three. Okay, supposed to guess. Everybody guess. Okay, everybody watch. Okay, so over here, go ahead and watch. And what do you see happening? How are they moving? I don't know if you can see that. They're going up and to the left is the answer. Down, right? If I reset, watch the sun, right? Up and to the left, 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 up and to the left. Okay, so the answer was up and to the left. Okay, here we go. Let's go. Let's draw this picture. Okay, so near the pole, the circle is small. That's not a very good circle, but this time it's going to go clockwise, right? It's going to go like the clock direction. When you're a little bit further, the circle is going to be larger. And it's still clockwise, right? Like the clock going around the circle. But if the circle is very large, what's going to happen? The star will not be visible all the time. It's going to actually go below the horizon. It's going to rise and it's going to set. So the size of the circle determines whether or not it's going to be able to be seen all the time, or if it's going to have to rise and set. And so now I want you to think for a moment about how this all is connected. And I want to tell you something important, that all of the stars are all moving in circles. All of them are moving in circles. So if you look over here in the west, what happened is that the circle is just so big that you can't see it, right? The reason we see it, we're going to see the stars rising and setting because they're very far away from either the north celestial pole or the south celestial pole. And actually, we see them rising and setting. It's kind of like the way we see a rainbow, right? A rainbow looks like an arc in the sky. How many people know that rainbows are circles? Everybody know that? Rainbows are circles, okay? But normally we don't see the full circle. We only see part of the circle, okay? All right, now I got a really beautiful input on the chat. I don't know if you noticed that or not. Somebody said something, and I want to make sure everybody sees it. So we were in Santa Barbara. We found out the stars went up and to the right because we're in the northern hemisphere. In the southern hemisphere, they go up and to the left. They do something a little bit different, and you want to be aware of that difference. But the rising angle in Santa Barbara was about 56 degrees. And somebody pointed out why 56 degrees is a special number. Who knows that? If you can say that again, why is 56 special? And why is it exactly the right number for Santa Barbara? Who remembers?
56 and 34 equals 90.
That's it. Okay. So everybody, you've heard of this principle before, that when two angles add up to 90 degrees, they are called complementary angles. And so I'll go ahead and write that down for you. This is something that happens in all of our situations. The rising angle plus the latitude angle add up to 90 degrees. And this is called, can everybody see that? This is called complementary angles. Complementary angles. Let's do that. Complementary angles. Okay. So if you know your latitude, how will you determine the rising angle? If you know your latitude, how do you find the rising angle? What would you do?
Subtract it from 90.
That's it. You do 90 minus your latitude. And that's it. Super easy. But now you have a rule that you can follow anywhere you go on Earth. You can find the rising angle exactly by what your latitude is. Okay? All right. So now we're going to get a chance to apply this brand new knowledge. Hopefully it'll make sense. Some of it may not, by the way, and that's okay. But we're going to try to help you understand. So everybody flip over to the back side, and we're going to do page 5B now. I'm going to do page 5B. So this one I'm going to hold like this. All right, here we go, page 5B. So we need to start off with the numbers for the latitudes. All right, so if you don't know it, we need to write it down. Does anybody know the latitude for the North Pole, right? What's the latitude for the North Pole? Need to know this. 90 degrees, but don't forget the direction. So we say 90 degrees north, put an N after it. Make sure you put the N. Okay, 90 degrees north. Thank you, Leah. That's great. What's our latitude in Santa Barbara? We made sure we know what that is. What is it? 34. 34 degrees. Don't forget, north, right? It's got to be the north. Okay, make sure you know that. And what is the latitude of the equator? What's the number for the equator? Which, by the way, is not north or south either, right? It's right on the equator. What's the number? 0 is right. So 0 degrees latitude is another way to talk about the equator. So here we go. Let's see if we can apply our new knowledge. Where was, actually, can we make need to make a correction. Cross off Polaris, because it's not exactly right. What's the point in the sky that doesn't actually move? What's the name of the point in the sky that doesn't move?
The North Celestial Pole.
Yeah, go ahead and put NCP for me. Go ahead and change that to NCP. I better correct this worksheet at some point, but we'll go ahead and do that, okay? So would you go ahead and try to remember what happens, right? In Santa Barbara, what was the altitude of the North Celestial Pole? Anybody remember the number?
34 degrees.
It was 34 degrees, which is the same as what?
Our latitude.
Same as our latitude. So what should it be for the North Pole?
92 or no?
It should be 90 degrees, right? 90 degrees, the same as the latitude. What should it be for the equator?
0.
It should be 0, okay? How about the rising angle? Let's go ahead and do the calculation. How do you find the rising angle? We just wrote this down. What's the formula? You do 90 minus
your latitude.
That's it. 90 minus the latitude. So what's 90 minus 90? Anybody?
0.
It's 0. What does that even mean? Actually, that's really weird, by the way. That's weird. And if the rising angle is 0, what's the setting angle?
0 too.
It's also 0. Right. Good. And in Santa Barbara, we did already. What's the rising angle in Santa Barbara?
56.
We found that. Yeah, I told you. 56. And the setting? 56. What will it be at the equator? What's 90 minus 0?
90.
It's 90. What does that mean, right? That's kind of a funny thing. And the setting angle, also 90. Okay. Now I want you to look right here where this is something we don't know, and we're going to learn about right now, is what is the number of NCC? So what does NCC stand for? Let's make a little note. NCC. What is that? What does that mean? So N stands for what direction?
North.
Northern. C stands for circumpolar. And the other C is constellation. So write that down. Northern, circumpolar, which means around the pole, constellation. These are constellations that you can see all night long, right? They don't rise and they don't set. So we're going to go ahead and go to all of these places on Earth, and we're going to see what we see, right? What do we see? So let's take a look, and we're going to start off by going to the North Pole. Okay, so let's go to the North Pole. It's kind of cool to see this. Actually, I'm going to turn off this celestial meridian again. We don't need that anymore. I'll leave the pole on though, so we'll do that. And we're going to change our location. And all we need to do is go click north and then change the number to 90 degrees. Hit enter. And now I'm not in the right place. Hold on, let's try it again. Try again. 90. And that didn't work. Okay, I'm gonna go really high. I'm gonna go 90. Period. There we go. Okay. I don't know what happened. It just took a little bit there. All right. So here I am. I'm at the North Pole. And by the way, where is the North Celestial Pole? It's right above me, right in the middle of the sky. Does everybody see that? It's right in the middle of the sky. Right in the middle of the sky. So when we watch the sky, right? Watch the sky. I'm going to start off by watching for the rising angle. What's the rising angle supposed to be at the North Pole? What's the number? Okay. What's the number? Anybody remember that number?
0.
It's supposed to be 0. Okay, so here we go. So we're going to watch this thing go forward. Okay, so we're going to watch this thing go forward. What does it mean to have a 0-degree rising angle? Okay, and the answer is 0 degrees. It's going to go up and to the right at an angle of 0 degrees. Which does that mean? It doesn't go up at all, right? All it does is circle around. The stars and the planets and the sun and the moon, they just circle around. This is a weird experience. I've never experienced this myself. But if you watch them, you understand all they're doing is moving in counterclockwise circles around the North Celestial Pole. But this line, this horizon that we see, which by the way is a little, let's go ahead and fix that. Let's go to the simplest horizon we can have. This horizon is actually the same thing as what we call the celestial equator. So this is actually the celestial equator. This is the same thing. Can everybody see the blue that's appearing on the edge of the circle? This is the celestial equator. And so how are the stars moving? The stars and the planets are moving with a 0-degree rising angle, just means circling around. And we are seeing all of the stars that are above the celestial equator, the top half of the celestial sphere. So that's a pretty big deal. So the last thing I want to share with you is how many constellations can we see? Let's turn on the constellations. And there are a lot of constellations. Look at all of them. Are any of the constellations rising and setting?
None.
None of them, right? They're all just circling around. So if you can see a constellation, you will always see that constellation. It will always be visible. So in fact, how many of the constellations in the sky are we seeing at this point from the North Pole of the Earth? Anybody know the number? So who knows the number of constellations in the sky? The actual number. Defined by there are 88 of them. How many can we see from the North Pole? So the answer is 44. That's right. Thank you, Juan. That's great. Okay, so everybody, we got that. Everybody got the number. Okay, so how many circumpolar constellations? 44. Half of all of the constellations can be seen from the North Pole. That's actually great. Okay. Now, what about Santa Barbara? Will it be the same? What do you think? Smaller, bigger, the same? What do you think? Type it in the chat. What do you think? Smaller, bigger, the same? How many constellations can be seen all night long? Mhm. Okay, you're not sure, William. That's okay. But try. You just tried, right? Okay. All right, so let's go ahead and try it. Go to, we're still making it work right now, but let's pause that. Okay. All right, we're going to change back to Santa Barbara location. I think I can just go, I don't know, home. Going to do home somewhere. Return to default. Return to default. Oh, that didn't work. Okay. Name of city. No, I got to just go here. Santa Barbara. Santa Barbara. Northern America. Okay, 34 degrees. Actually, it's close to 34 and a half. That's funny. Okay. So we're going to go look in the north. Okay. This is a little interesting here. Okay. So the North Celestial Pole is here. Can you see any constellations all night long? Okay, so we want to look at this, all right? So Ursa Major, if there were no mountains, we would always see some of the stars of Ursa Major, always, right? Because of the mountains, we lose them. They go away. Here's a constellation you'll be learning later called Draco. We can always see some of Draco. Ursa Minor, of course, we see all the time. Another constellation we'll learn, Cepheus. We see that all the time. Cassiopeia, again, if it wasn't for the mountains, we would see all of that. Camelopardalis, which is the camel leopard. We see most of that. Ursa Major, we see most of that. Lynx, we see some of that. Leo Minor, some of that. Okay. So depending on how you want to count it, right? Should we count it if you can see the whole thing, or count it if we can see some of it? What do you think? It's up to us. But I'm going to go ahead and tell you my official answer. And the official answer is that we're going to use the if we can see it at all. And so I want you to write the official answer, which is a few. Okay, the official answer is a few, right? It's not many, it's a few. Okay. So, and we already looked at the stars rising and setting, but let's now make sure we study what happens carefully when you go to the equator, right? So we're going to go to the equator, and we understand the rising angle is 90 degrees. What does that even mean, right? What does that mean to go at a rising angle of 90 degrees? Okay, so change the location, and this time we're going to go 0. That's 0. That's the equator right there. And we're going to watch. We're going to go look to the east. Look at the east. Okay, here we go. The east. How did the stars rise? It says 90 degrees. What does it mean, right? So I want you to guess. Is it mean straight up and to the right, or up and to the left? What do you think? Guess what it means. 90-degree rising angle. What does it mean? Okay. All right. Good for you. Thank you for guessing. Okay, now watch some of these stars over here. Okay, watch them, and you're going to see what happens, right? Watch them. Okay, one. What are they doing? Anybody see? They're moving straight up. That's right. They're moving just straight up in the air. They go straight up. And how are they going to set over here in the west? How are they going to move in the west when we look at the stars? They're going to move straight down. They just move straight down. And so this is kind of funny. It's actually something that you'll notice. It's a little weird. When stars are setting, rising and setting on the equator, they really rise and set very quickly because they go straight up and straight down. All right, now look to the north. Where is the North Celestial Pole? Where is it? Can you notice? And that's the star we call Polaris, which is Mismar. What is going on with that? I'm going to look that up. It says Alpha Ursa Minor, which is also known as Polaris. I do not understand what we're talking about here. What the heck is Mismar? This is something really weird to me. I better go look that up. But don't worry, that's Polaris. I don't know why it's doing that. Anybody see what's the altitude? The altitude is right on the horizon. So the number would be what? The number is 0 degrees. Okay. Now I want to do something really kind of interesting. I want you to point to the south part of the sky, and I want you to notice something is on the southern horizon. What do you see? What's the point on the southern horizon? What's SCP stand for?
North Celestial Pole.
Yeah, so NCP is at North Celestial Pole, but SCP stands for
the South Celestial Pole.
the South Celestial Pole. So you see it right on the southern horizon, and you see the North Celestial Pole right on the northern horizon, right? Now, how many constellations will be seen all night long? How do they move around the North Celestial Pole again? Anybody remember the direction? How do they move? Say it out loud.
Counterclockwise.
They move in counterclockwise circles, right? Counterclockwise circles. And so if you watch them, how many of them will remain up all night long? How many constellations will remain up all night long? As they go around the NCP, how many will go up and will stay up all night long? Anybody?
44.
That's a good guess. Actually, we can see all 88 constellations throughout the year. But if you look carefully, you'll notice that every constellation has to go below the horizon because it's going around the NCP. So none of the constellations will be visible all night long. None of them. Does that make sense? Why 0 is the right answer? You guys understand that? So the answer is 0. None of them. Okay. Oh my gosh, it's the Arabic name. Thank you, Kai, so much. That was interesting. I don't know why it turned on though. I wonder if I turned on something about Arabic names. I bet I did. Okay, so I want to put down the answer. There are no constellations visible all night long from the equator. Nothing will stay up all night long because as they go around the pole, they have to go below the horizon, so they won't be up. All right, here we go. We're keep on moving. We got to get through this worksheet today. How would you define latitude, which we've kind of defined last week? Has anybody, get out your notes or say it for yourself? How would you define latitude? What's a way to define latitude?
Degrees north or south.
Okay, great. It's an measure starting from where? Measured
The
from where?
equator.
Measured from the equator. And measured from the equator. And I like what you said. So I'm going to put that from the equator and north or south, right? North or south. Okay, north or south. So what are the numbers that you can have? What's the smallest number you can have for latitude? 0 degrees, right? I already have a degree mark. Okay, I can leave that. So 0, what's the biggest number you can have for latitude? Biggest number is 90, except you can actually go in 2 directions, right? 0 to 90 north, or I'm going to add this, or 0 to 90 S, right? You can go either direction. So the numbers can go between 0 and 90. And okay, so actually, I just realized you didn't see Kai's message. Kai found a really cool thing. In medieval Islamic astronomy, Polaris was known as Mizmar. So that is the Arabic name for Polaris. I don't know. I never learned that. I have just learned something new. Thank you, Kai, very much for finding that. Okay, define altitude. Altitude. What does the altitude mean? Anybody remember? An angle measured how? An angle measured
Above the horizon.
above the horizon. An angle measured above the horizon. So we don't usually talk about negative altitudes. We're just talking about above the horizon. So what's the smallest number altitude can be? If you're on the horizon, what's the number? So 0, and the highest number you can get to is what? 90 degrees, okay? The biggest number is 90 degrees. Okay, so what is the relationship between your latitude and the altitude of that? Wait, cross that off. We don't want North Star. What do we want? The point in the sky that doesn't move. What's it called? The NCP. Please correct. Make that NCP. What is the relationship between your latitude and the altitude of the NCP? Anybody remember that? What's the relationship? You can look right here, right? What do you notice?
The same.
They're the same. They are the same. Okay, they're the same. Actually, that is something that's kind of cool. No matter where you go on Earth, if you want to know where the pole is, it's the same as your latitude. The latitude is the key parameter for your location on Earth. What is the relationship between your latitude and the rising and setting angle? So what was the relationship? And we could say, when we say relationship, what's the equation? How would I write down the rising angle equation? We already wrote it down. What is the number? What's the equation? The rising angle is
90 minus your latitude.
That's it. 90 minus your latitude. We have a nice simple formula. You're going to need to memorize that formula, by the way, in case you were wondering why I'm telling you this. You need to memorize that formula. The rising angle, how the stars move, is just the complementary angle to your latitude, or 90 minus your latitude. So if you know your latitude, you can automatically figure out what that rising angle will be. Okay. So we're now going to jump down to our final piece of this worksheet, and you have a chance to work on your own for a second. So I'm going to just give you a minute here, a couple minutes. What is the altitude of the NCP? Fix that. NCP. What the moon sets at what angle? The setting angle for the sun. The setting stars angle for San Francisco, which is 38 degrees north latitude. I'm going to give you 2 minutes to finish those problems by yourself. Okay, go ahead and do them by yourself, and we'll check your answers in a moment. Okay, 2 minutes. I think I gave you 2 minutes. What is the altitude of the NCP in San Francisco? Anybody tell me the number? What should it be?
38 degrees.
38 degrees is perfect. Everybody got 38 degrees. If you did not, fix it. 38 degrees is the right answer. Okay, now what is the setting angle for the moon at this location? Anybody want to, you could type it in the chat if you want to say it out loud. What's the setting angle?
Would it be 90 minus 38?
It would be. What's that? What does that give you?
52.
52 degrees. And what you want to understand is it doesn't matter what's rising and what's setting. The rising and setting angles have nothing to do with the object. They're all the same. So what's the setting angle of the sun? It's also 52 degrees. What's the setting angle for the stars? It would also be 52 degrees. It's all the same, 52 degrees. Sorry to bore you, but that's what it is. Okay. So what we're going to do, our final little piece, we actually, and then I want to make sure I get you ready for your quiz, because you have a quiz to take after this. Our final little piece is to talk about the concept of twilight. All right. So I want to look at you guys again. It's actually really, I'm remembering how sad I was during COVID times when I couldn't be with my students. You're my students and I can't be with you. So, you know, it was kind of sad. Anyways, I'm remembering how hard that was. Does anybody remember, or do you know what twilight is? What is twilight? Anybody heard of that term, twilight? Okay, yes, it's a set of books about vampires. That's right.
I was gonna say.
Oh, that's my wife. She says, I was going to say that. Okay. Anybody remember? Twilight. What's twilight? Is it light or is it dark? How about that? During twilight.
It's a transition from one to the other.
Very good. That's great, actually. Great word. I love that. I love your definition. Is the sun up or down, though? How about that? During twilight. Is
Is
the sun visible or not?
The sun wouldn't be visible.
No.
That's right. If the sun is up, it's daytime. Let's be very clear. That's daytime. But the moment the sun is below the horizon, and we can still see, right? Some of the light of the sun is somehow making it to us. We're not worried about the mechanism or how that's happening, but somehow the light of the sun makes it to us, and we can still see, even though the sun is below the horizon. So let's see. The sun is below the horizon, but you can still see something. We call this twilight. And you're going to be learning there's actually 3 different types of twilight, 3 different names for twilight, 3 different levels of twilight, and you're going to try to understand what those correspond to. Okay, but really we want to also talk about is how does it feel? How would it be? How would you experience twilight in different parts of the world, right? How would it, what would the experience be like? Okay, so our final piece is take a look, is this worksheet. You'll notice that they put a little double arrow. And does everybody remember this? What does 15 degrees equals 1 hour mean? What does this refer to? Anybody remember that? We did this calculation last week.
Equal longitude.
It is, okay, that's true. It is the difference in longitude is 1 hour of, actually, that's great. If you didn't know this, somebody just said something kind of cool. If you look at the time zones, every time zone is approximately 15 degrees different in longitude from the time zone before it. So as you move across time zones, yes, 15 degrees of longitude is in fact the right way to talk about it. But this has something to do with the motion of the sky. And so do you remember what this was? 15 degrees every hour?
15 times 24 equals 360.
Exactly. This was the number of degrees the Earth rotates in 24 hours. If you divide 360 by 24, thank you, Winnie, that was perfect, you get 15 degrees per hour. And because the Earth is rotating, this is exactly how fast the sky is moving. So if you watch a star and you say, okay, there you are, star, I see you. In 1 hour, how many degrees will it be from where it started? The answer is 15 degrees away. Every hour, it will move 15 degrees through the sky. And so this is actually a really, really neat thing for us to understand. If you remember, there's actually a trick. Again, if I were with you in person, I would be having you do this. But if you hold your fist out and these fingers are sticking out, the distance between these fingers at arm's length, right? I have to hold it out. I can't do this. I have to be off screen if I do that. But if you hold it out at arm's length, they're about 15 degrees apart. You could hold that up in the sky next to a star, and you know where the star is going to be if you have some sense of how it's moving, right? If it's in the south, it's going to move across the sky to the right, 15 degrees, one of these little pieces, right? Just like that. All right, so now let's go ahead and look at our worksheet. We're going to start off with Oslo, Norway. Has anyone been to Oslo? I would be very curious to know if anybody's been there. We are talking about Norway. Yes. Okay. Awesome. Cool. What do you like? Do you like it? Is it cool? It's a big city, big, exciting city. I think it would be fun. I'd like to go there, but I think the summertime would be better for me. Okay. Anyways, back to Oslo. Okay. So now we know the latitude. Right above the latitude, I want to write this down. I want to write setting angle equals, okay? And you want to write it too. Right above the Oslo, Norway, put the setting angle equals. And what is the setting angle going to be? Can you figure that out? If the latitude is 60, what is the setting angle? I'm looking for someone to type a number in the chat or say it out loud, one or the other. Thank you. 30 degrees is correct. Okay. But the last thing we want to remember is how does the sun set? Does it go straight down? Does it go down and to the left or down and to the right? What's the right answer? How will the sun set in the northern hemisphere? Down and to the right. Okay, here we go. We're going to put the sun right on the horizon. It's setting. So I want to imagine that I can only see half of the sun. Just put a little semicircle. The other half is below the horizon, right? And there's a dot right there. That's the center of the sun, is right on the horizon. And I want to think about that. It's right in the middle of the horizon right now. Where did it come from? Where was it before it got here? Well, it came down and to the right to get to that position. So I'm going to go ahead and I'm going to put a line, a dotted line, something like that. A dotted line. Can you guys all see my dotted line? And I want to indicate what this angle is. What's the setting angle? 30 degrees. Okay, 30 degrees. Where was the sun 1 hour before? This is sunset, by the way. This is sunset, right? The sun is on the horizon. Where was the sun 1 hour before sunset? And the answer is 15 degrees away from this point, right? 15 degrees. So I'm going to go up this line, one of these double arrows, just right here. Okay, I'm going to go 1 hour before sunset. 1 hour before sunset. I'm going to put the sun 1 hour before sunset. Where will the sun be 1 hour after sunset, right? Now that the sun has set, it's now going to be below the horizon, but it's going to follow the same exact line, right? That 30-degree angle line. And so here's my sun 1 hour after sunset. Everybody understand that's what's going on. The sun is moving 15 degrees across the sky every hour. All right. Now we go to Santa Barbara. What is the setting angle in Santa Barbara? So we know the number. What's
56 degrees.
56 degrees. Now, if you and I are friendly, I'm going to go ahead and say 56 is pretty close to 60, and 60 is about twice as big as 30. So instead of a 30, I'm going to make it like twice as big. Put the sun right in the middle of the sky here. But now instead of a 30-degree, I'm going to make like a 60-degree angle. It's supposed to be twice as big, right? Not 60. I just about twice as big. It's really supposed to be 56 degrees. Okay. So where was the sun 1 hour before sunset? Well, it was above the horizon, 15 degrees along this line, right? It will be 15 degrees along this line. And where will it be 1 hour after sunset? It will be 15 degrees below the setting sun. It'll be below the setting sun, but it's following that path, right? That setting angle path is unique for the latitude. It's actually what it is for that latitude. Okay, our last one. You're at Quito, Ecuador, and so what's the setting angle? You're on the equator. 90, thank you. That 90 degrees. Now that happens to be the easiest one of all, because now I'm going to put my sun right here, right here, and I'm going to put this line right there. That's my dotted line, just like that. Everybody know the symbol right here? This is the right angle symbol. If you haven't seen that before, please put it in there, because I'll try to use that sometimes in our class. And I want to quickly be able to say, hey, that's a right angle, 90 degrees. We call it a right angle, right? 90 degrees is a right angle. So where would the sun be 1 hour before sunset? It's going to be 15 degrees, right? Above this place, along this line, it's going to be right here. Okay, all the way straight up. Okay, and where's it going to be 1 hour after sunset? It's going to be down here. Okay. All right, now you can see that this is different, right? The different latitudes have different setting suns. In which three of these situations is there the most light? In which one of these do you have the most light? There's still the most sunlight. What would you guess?
Ecuador.
Okay, that's a good guess. On the equator, okay. But actually, it's not the equator, and I'm going to explain why. The further below the horizon the sun goes, the harder it is to see the light of the sun. So in Ecuador, it's actually 15 degrees below the horizon, 1 hour after sunset. But in this picture, is this distance going to be 15 degrees or something smaller than 15 degrees? And the answer is it's got to be smaller, right? It's not 15 degrees, it's something smaller than 15. And how about this picture? Is it 15 or smaller than 15? And the answer is, which one is the smallest distance below the horizon? And the answer is Oslo, Norway. The sun is only going to be, actually, if you know trigonometry, does anybody know the number? It's only going to be 7.5 degrees. You don't have to know this. That's a little too much math. But if you did the calculation, it's only 7.5 degrees below the horizon. Whereas over here, it's 15 degrees below the horizon. So which one's darker? Quito is darker and Oslo is lighter because the sun is not as far below the horizon. Does everybody understand that idea? The further below the horizon, the darker it becomes. Okay, so what is twilight and where would the shortest twilight occur? Okay, so try to do that. Try to answer that question. And then I'm going to tell you the right answer and make sure you have the right answer when we're done. What is twilight in your own words? And where would twilight be the shortest, right? Where would the shortest twilight occur? Okay, so I'm going to start answering the question. Anybody want to say their answer out loud? What is twilight? We kind of talked about it a little bit before. So where's the sun when it's twilight? The sun is below the horizon. But we can see, right? We can see some light. And so which one has the fastest or the shortest amount of twilight? Anybody want to guess? Help me out here. You make me feel good. Dun, 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 dun. Okay, nobody's answering. Is anybody there? Hello? Where do you get the shortest twilight?
Is it Oslo?
That's right. Where? At
Oslo?
No, that's going to be the longest twilight. Does take the longest amount of time to get quiet, to get tired. Yeah. So the answer is Quito because the sun is going straight down as fast as it can away from the horizon. It can't go any faster than this, right? In 1 hour, it's 15 degrees from the horizon, below the horizon. In 2 hours, it's 30 degrees below the horizon. It's very quickly going down. So this is the shortest twilight. So shortest is in Quito. Okay. So what do you notice happens? The larger the latitude, the smaller the setting angle will be, right? And the smaller the setting angle, what does this do? Does it make it a longer or shorter twilight? Because it's a smaller angle, what happens? It's a longer twilight. So when we, down here, it says make a general statement comparing the length of twilight with the latitude. We could start off with this. The greater the latitude, and how would you complete it? The greater the latitude, the longer or shorter? So the answer Kai gave me.
Twilight.
Yes, the longer the twilight. Okay, the longer the twilight will be. Okay, so I have a couple things I want to do with you. I want you to see this for yourself. And so I'm going to go ahead and go back to Stellarium, but I'm going to do something a little different. I'm going to, I think am I on the equator still? I think I might be. I'm going to turn on the atmosphere again so that I can see. Oh, there it is. Okay. So I want to do this. I'm in the west, so the sun is setting, right? I want to just, let's see. Let's go. Actually, how do I know the sun is setting? I can't see it. Actually, I can't see it. It's not up. Okay, hold on. Here comes the sun. There we go. That's our sun. If we look over here, the altitude of the sun, let's pause this. Hold on. Is the altitude is 0 degrees 43 minutes. Okay, if I go forward, it's going to go down 0 degrees. There we go. Oh, it's too below, too far. Okay. So the center of the sun is right about on the horizon right now. Okay. So this is the sunset. This is 1 hour before sunset. Sunset. 1 hour after sunset is actually pretty dark already. Okay. And the reason is that the sun is below the horizon. And here it is, 15 degrees below the horizon, approximately. Okay. So let's go to Santa Barbara. Let's go to Santa Barbara. So I go over here, location, and I'm going to go Santa Barbara. North America, that's us. Okay. And I'm going to back up just a little bit. Look at the altitude of the sun. It looks like I'm a little bit below. Here we go, getting closer. Okay, so the sun is on the horizon. There it is. Okay, so let's try it. So 1 hour before sunset, it's up there, right? Sunset and 1 hour after sunset. Well, it looks pretty dark. Still looks pretty dark. I can't tell the difference. Oh, there's a little glow. You see the little glow? I see a little glow. It's hard to see though. I don't think my simulation is really giving you a great indication. So just, whatever. We'll see. Okay. And the last one, let's go to Oslo, Norway. Let's see if this looks better. We'll go to Oslo. Oslo, Norway, Northern Europe. Okay. About 60 degrees. Okay. And we're going to watch in the west. We're going to go back with the sun. There it is. Okay. The sun. Okay. So put the sun near the horizon. Oh, too far. I can't see. Hold on. Let's try it again. Okay, so moving forward. 3, 2, 1 degree. Okay, right around there. Okay, so 1 hour before sunset. Sunset, 1 hour after sunset. You can still see, ooh, look at the glow. It's much stronger than either of the previous two. There's still a lot of sunlight showing up, right? So this is the idea. The closer the sun is to the horizon, the more light you'll be able to see, the brighter the twilight will be. Okay, everybody understand that? That's a key thing. So we're going to now look at some quantitative thing right here. I'm going to Canvas. This is the content that we talked about. I didn't talk too much about this, but yeah, maybe I will. But we're going to talk specifically about twilight. There's actually 3 different kinds of twilight. So if you want to look right here, the twilight is defined by how many degrees the sun is below the horizon. So if you are between 0 and 6 degrees, it is called civil twilight. So the sun is below the horizon, but not too far, within 6 degrees of the horizon. There's a lot of light. You really have a lot of light. So it's called civil twilight. You can work. There's enough light for you to work. Not a problem. Now, if you go a little bit lower, between 6 and 12 degrees, we call this nautical twilight. And the reason is if you're working on a boat, there's still enough light for you to see ropes or, whatever it is you're working with. You can still function. Okay. So there's nautical twilight. And finally, the one that you and I are concerned about. If you have between 12 degrees below the horizon, the sun is 12 to 18. This is called astronomical twilight. When it finally goes 18 degrees below the horizon, it's going to be dark. We really won't be able to see any sunlight at all. And so this is the moment where we truly will see the darkness of the sky and be able to see our best view of the stars. Okay, so this is actually what we're waiting for. But the reason it takes a little while to see the stars at night is because of this concept of twilight. So the further down the sun goes below the horizon, the more we will see the stars. Okay, so that's an important concept that you're supposed to get. Okay, so we are pretty close to being done. Remember, there's going to be a quiz. In order for you to get 100% on your quiz, I want to just make sure one more time you see something, some important ideas. So the thing that I haven't done a lot with you is work with the Southern Hemisphere. So I just want to take a few minutes to remind you how different it is in the Southern Hemisphere. So you'll be learning more as we progress, but I just want to take a moment to go over how that works again. So I'm going to look at stellarium and I'm going to jump to a place in the Southern Hemisphere. Okay, so let's go to stellarium. And we're going to jump. I'll show you what I'm doing. You don't have to, I'm not trying to hide it from you. I'm going to just jump. Let's go to Australia. Or Madagascar. Let's go to Madagascar, somewhere over here. Madagascar. Okay. 20 degrees south. Okay. 20 degrees, 19 minutes, 21.29 seconds. Okay. So I want to start off, first of all, with looking in the south. Okay. I want you to look in the south. So you look in the south and you'll notice, we'll turn off these constellations. We don't need to see them. You'll notice there's the SCP. It's above the horizon. I need your help. What is the altitude of the SCP above the horizon? Somebody tell me the number. What's the number? What's the altitude going to be?
$20.
That's right. Take a look. Just slightly more than 20 degrees. Here's 10 and 20. It was 19 minutes too, right? So, but just a little bit more than 20 degrees. Isn't that cool? That's exactly where it is. So if you know the latitude, you know where the pole is going to be. How do the stars move when they're near the South Celestial Pole? How do they move? How do they move? How would you describe that? Okay. You guys all know the word, right? What's the word? Clockwise circles. They move on circles in clockwise circles. Okay. And all right. So pause. Okay. Now look over here in the east. I want you to look at something. Okay. What is the rising angle at this latitude? What is the rising angle? What's the rising angle where the stars and the planets and everything are going to rise? So if 20 degrees south is the latitude, what's the rising angle? I got 70. Thank you, Juan. Thank you so much. Okay, so I want you to notice something, and that is, how do the stars and the planet and the sun rise in the southern hemisphere? Do they go straight up and to the right, or up and to the left? What's the answer? And you can unmute yourself or just type it, but you want to make sure you know the answer. They are up and to the left, right? Look at them go. Up and to the left, up and to the left, up and to the left, up and to the left. Okay. And in fact, they're going up, and this angle between the horizon and the direction they're going is going to be 70 degrees. So what is this line that you see right here? This is the celestial equator. That's the celestial equator. In fact, all the stars and the planets and the sun are actually going to follow the direction that the celestial equator makes with the horizon. And this is the 70-degree angle. So we see them rising in the east. And then as they go through the sky, let's take Jupiter. Let's take Jupiter. Let's do this. Let's watch Jupiter. Let's watch Jupiter go through its arc, right? It's going to follow an arc in the sky. And in fact, it's going around what point in the sky? What is it moving around? What point in the sky is Jupiter actually going to be moving around? Okay, the answer is either the North Celestial Pole or the South Celestial Pole. That's the answer. But the size of the circle, watch the circle. It's so big that you can't see the full circle, right? And in fact, the North Celestial Pole is below the horizon. I can't see it. If you watch Jupiter, it makes this arc through the sky. It goes up at a 70-degree angle. When it's in the middle of the sky, it goes horizontally to the left in this case, right, as I look to the north. And then it comes down, and as it hits the horizon, it's coming down at a 70-degree angle. So to the horizon. So things are always moving on circles, and they always rise in the east and they always set in the west, but they're actually moving on giant circles around the poles, the south or the north celestial pole, one or the other. Okay. Right. All right. So that might be it. What else am I going to do here with you? Okay. So did you learn anything? You guys got anything? You learned a few things? Yes, no, maybe? Okay.
Yeah.
Yeah. Okay.
Yeah.
All right. So here's what we're going to do. I am actually pretty much done. If you have any questions, you can stay and ask questions. But otherwise, what you're going to do is wait for that quiz to open up. It's supposed to open in about 20 minutes. Sorry about that. I could open it up early. Who wants me to open up early? Anybody?
Me.
Want to take the quiz? Okay.
Me.
I'll open it up early.
Me.
And then
When is
what
it
you're
due?
going to do is take that, and if you don't get 10, you don't get all the questions right, try it again. And you get 3 tries altogether. Oh, you're very welcome. Thank you, everybody. Thank you for being here tonight. And hopefully next week everything is cool and we will meet at the planetarium. So thank you guys for being here tonight. That's it. If you have questions, stay. Otherwise, see you later. Have a good night. Sweet
Bye. Thank
dreams.
you.
You're welcome. Bye. Thank you for coming.
Thank you.
Bye.
Bye. Thank you.
Thank
Go.
you.
All right.
John, I have a question.
Sure. Ask a question. Yeah.
For next week, are the normal times still like
The
in
normal
place?
times. Yeah.
So
We're
like,
not gonna change the schedule. So
okay,
yeah, I'm sorry. It's just, yeah, it is what it is.
okay, great. Thank you.
Absolutely. Thank you.
So next week the lab will be at 4 o'clock again.
Which group are you in? A or B?
B.
Okay, so let's take a look. I will tell you the answer. So we go to home, and B is next week is the 12th. Yep, 4 o'clock. That's right. That's it. You can always
Thank
check
you.
it there. You're very welcome. Thank you for coming. Hey, Jordan. Thanks for coming, man.